All right, very exciting. We are on our last lesson of this chapter before our chapter test. And today we're talking about isosceles and equilateral triangles. So if you remember, an isosceles triangle is one that looks like this up here, where two sides are congruent. Notice, see, these two sides are marked congruent. The congruent sides are called the legs. We refer to them as the legs of the triangle. And then these angles at the bottom, we call the base angles. And the angle up top here, we call the vertex angle. So as we refer to the parts of the triangle, that's how we're going to do it. So when you have an isosceles triangle, we're going to talk about this theorem now. If you have an isosceles triangle, that is that the sides, two sides are congruent, then those base angles are congruent. So that always will be the case. Anytime you have an isosceles triangle, if the sides are congruent, then the base angles are congruent. And it goes the other way too. That is, if you have a triangle that has the base angles congruent, then you know the sides are congruent. If there's one, there's both. Can't have one without the other. Now, when you have an equilateral triangle means all sides congruent that we see here. So if all the sides are congruent, well, then all the angles are congruent. And more specifically, because the sum of the angles has to equal 180, they all have to be 60 degrees. So anytime you have an equilateral triangle where all the sides are congruent, the sides obviously can be different measurements, but all the angles will always be 60 degrees. And just like with the isosceles triangles, if all the angles are congruent, then all the sides are congruent. So you can't have one without the other, because there is a relationship between sides of a triangle and the angles opposite them. Well, let's see what these problems will look like. When you have, we're looking at number 1 here, notice these are the congruent sides, and the base angles are always opposite those congruent sides. If you need to turn your paper, your iPad, so that it looks more like this, do it, right? But because the sides are congruent and then the base angles are congruent, we know that x has to be 55 degrees. They have to be congruent. Similarly, this one here, if those sides are congruent, it means these base angles are congruent. So x has to be 36 degrees. For number 3, notice all the sides are congruent, which means all the angles are 60 degrees. So x is 60 degrees. Now, before you get all excited like, woo, this is going to be the easiest lesson in the world, number 4 is different. See how number 4 is different? If these two sides are congruent, that means these two angles are congruent. So this is also 70. So x is not one of the base angles in this case. Then we need to use the fact that the sum of the angles of a triangle equals 180. So we're going to do 70 plus x equals 180. Or x plus 140 equals 180. Whoops. Subtract 140 from both sides, and we get x equals 40. So we have to do a little bit of work there, but we're still using the property that the base angles are congruent. Now, for these last problems, it's even more interesting because it's kind of like we're finding angle 2, but then it also tells us that angle 2 is equal to 6x plus 6. So first of all, we look at the triangle and we say, oop, all these have to be 60 because it's an equilateral triangle. So we know that angle 2 is also equal to 60 degrees. So our equation is going to be 6x plus 6 has to equal 60 degrees. Again, so using the triangle, we know angle 2 has to be 60 degrees, so we're going to set our equation equal to 60. Now when we solve it, we get x equals 9. Remember, in these cases, when we're solving an equation like this, x could be negative as well. So here we have, oh, this one is really interesting. So these are our base angles, so this is also 54. So first of all, we got to figure out the angle measurement of angle 2. So we're going to do, oh gosh, it's going to be weird. I can't really use a 2. You know what? I'm going to call it y. I'm going to call angle 2y right now. So just like up above, we have 54 plus y equals 180. So y plus 108 equals 180. And subtracting 108 from both sides, we get y equals 72. So this angle is 72 degrees. So now we have to, isn't this fun? Now we have to write that equation. So we know that that angle is 72, and so now we can solve for x. So we're going to do 7x plus 2 equals 72, minus 2 minus 2, 7x equals 70, x equals 10. Whoa, that encroached on the other one. But that's okay, I got lots of space underneath. All right, so this one, not so bad. These have to be congruent. So I know this is 45, so I'm going to make that equal to 45. So 2x plus 21 equals 45, minus 21. 2x equals 24, x equals 12. And finally, oh, we end on a hard one. I love it. Finally, this is 54. And so just like up above, I'm going to call that y for now if I have to solve for it. So y plus 54 plus 54. Oh my goodness. This is actually just like this one. How about that? I didn't even notice that. So, well, we can finish solving it. But it's going to look just like that one above. Oh, my pencil's glitching. There we go. Y equals 72. So now I'm going to set that equal to 72. And so I have x plus 83 equals 72. Oh, remember I warned you our answers could be negative. So x equals negative 11. And that can happen because we're solving that equation. It doesn't mean the, remember the measurement of this angle y is 72. It just x equals negative 11 based on the equation. So there you go. You're going to have a worksheet to do today that will have problems similar to these. We'll start off easy like this, right? And then we'll finish up with these harder ones. Good luck.